Alright guys, I'm back here. Sorry, I ran out of time on my last video, so we had to break it up into two. I've got two more examples to run through and then some for you guys to try. So for this one here, we want to prove that the two triangles are similar, and I have Zippo for information. But what I do have are two rotated triangles. So I have this central point here that they're being rotated around, and you'll notice the special arrows I have on my two sides here, which indicate that these guys are parallel. So when I see parallel lines, I think Z pattern, C pattern, F pattern. This guy in particular is my Z pattern. We can make that letter Z, and we know that because of the Z pattern, those two angles are equal. And also because of the Z pattern, if we do a backward Z, also known as an S, that these two angles are equal. And we only need to prove two, but hey, why not go all out? These guys are also going to be equal because of opposite angle theorem. So to just state that nice and clearly, angle P is equal to angle A, angle D is equal to angle X. These are both because of the Z pattern. And angle F is equal to angle F because of opposite angle theorem. They're just opposite of each other. So because we've proved that, therefore, triangle PDF, and I can do this real quick because I've got all three of the angles set up here, is equal to triangle AXF. And again, notice PDF are the three in the one triangle, so I put those ones first, and then AXF are in the second triangle, and I put those second because of angle-angle similarity. Next one. So this one here, we've got two nested triangles, so the smaller triangle inside the bigger triangle. Right off the bat, we have a shared angle. Angle A from one is equal to angle A from the other because it's shared. So we only actually need to prove one other, but because it's easy, I'm going to do both of them. B and C we know are equal because of the F pattern. E and D we know are equal because of the F pattern. So angle E, so I'm looking at my smaller triangle first, is equal to angle D. And poof, the rest show up. Angle B equals angle C is our other set, and those two are because of the F pattern. So therefore, we can say that triangle, and again, they're nicely lined up here for me, ABE is similar to triangle ACD because of angle-angle similarity. So the next three, I believe, or no, four questions are for you guys to try. I'm not going to scroll all the way down there, I just did the answers. But it says you try. So check out the one at the bottom as well as the next page. There are three to try. So pause up the video and then I will flash the solutions up here for you to check once you're done. Okay? Hit pause, give them a try. All right, so the solution for E is here. I did some nice color coding to try to help indicate what's going on and how to write that similarity statement at the end, but you should have got that they are similar here, and the reason for similarity is side-side-side similarity. So I've just matched up biggest side to biggest side, and I color coded them, as you can see, yellow lines, red lines, purple lines, although these don't match, but you get the rough idea. When I go to write my similarity statement, it's a little bit easier if I have that color coding to help me match up. So it FB, so I went from where it was purple and red, and then I just connected going around. This one's not so bad because the orientation is the same. So if you want to look in more detail, just pause. Otherwise, I'm going to jump here to the next page. So with F, okay, again, we have two sets of angles here that are equal, so I can prove that these guys are similar with angle-angle similarity. But trying to write that similarity statement, I did the red line going from the two known angles, and I did the same on this shape. And then I went from the X to the other, from the X to the other, and I did them in the same color, from the O to that third angle, and from the O to that third angle, I did them in purple to help me write my similarity statement. So here I started with A. The first one, you can do whatever order you want. So I went A, B, C. So I went along the yellow, through the purple, through the red. So I had to go yellow to purple to red, and you follow that same letter pattern. This guy down here, this is one of those side angle sides. So that angle R in the middle there, I know that they're the same because of opposite angles. I couldn't use my Z pattern here because it isn't indicated these are parallel. Now, we know now that they are because we've proved it's similar otherwise, but we'll have to use our angle, or our side lengths, right, rather. So this 16 here actually matches up with the 24 here. But the way we know that when we're doing this is the smaller angle, or smaller side rather, using the wrong words here, smaller side matches up with the smaller side in the other triangle. bigger side matches up with the bigger side. And H, this one's tricky, so kudos to you if you got it. It's separated into two separate similar triangles. So it's not actually this smaller triangle on the left and the smaller triangle here on the right that are similar. It's the lower triangle with the whole entire large triangle. So what you want to look is that triangle EDG, the whole thing, compared with this lower portion. And although this side is shared, they're matching up. This is actually the bigger of the two when we look at the smaller triangle, but it's the smaller of the two we know when we look at the big triangle. So you'll notice how for one, the 8's on the bottom, the other one's it's on the top. So this is how this one works out, and they are similar because of side angle side, of course, with this angle G being shared between the two triangles. So that is it. That was a long one today. But I will see you in class tomorrow, and we're going to reinforce some of these concepts then. Awesome.